So, given that that's 72 degrees, 21, and 22, we've got these things set up. This sets up really nice for a law of sines problem. Do I have a power couple? What two things do I know across from each other? 72 and 21. I know A and alpha, those two things to go together. So with that information right there, I can set up a law of sines problem. Remember what that looks like. Sine of the angle, so sine of 72 degrees over its side length that goes with it, which is that A of 21, is going to be equal to, we can use that to solve for anything here. Okay? So they told me C. That's the only other bit of information I know. I know C. So what am I going to use C to help me find? The angle that goes with C. Good. So the angle that goes with C is gamma. So I'm going to set up a sine of gamma. That's the angle. I don't put 22 there because that's a side length. I'm going to put the side length on bottom. I'm going to make it equal to gamma. Questions to that point? We got our setup. From there, we're going to cross multiply just like before. So we're taking 22 times sine of 72 equals 21 times sine of gamma. Yeah. So in my calculator, we'll start to put that together. Where did my calculator go? It's gone. All right, so we're turning on my calculator here. We're typing in 22 times sine of 72. I'm trying to solve for gamma, so I haven't done that yet. Eric, what do I still need to get rid of? 21. How do I get rid of that? Divide both sides by 21. Good. So I take that answer, divide it by 21. I get 0.996 equals sine of gamma. Not gamma, but sine of gamma. So, Savannah, what am I going to do to get rid of that sine? Take the inverse. So you could write this out and be like 0.996 equals sine of gamma. And what we're going to do here is we're going to do inverse sine on both sides. Okay, I don't normally write that out, but look how we type this into our calculator because you can save some time here. Second sine, okay, and I really just want to do the sine of that number, 0.996. You could copy down the decimals, but that's somewhat annoying to me. So instead, I want to copy and paste that in. So in our calculator, we're going to hit the second button, and then we're going to use this negative key down here. Okay, see right above that negative key where it says A and S? That's what we're going to do. So it takes the inverse sign of that answer. So second, and then the negative key to give me A and S. Hit enter. There's my answer. Instead of me having to retype it in, you can just type it in if you want to, but it's obviously faster if you use that button. Okay, so gamma is going to be equal to 85.1 degree. We're going to angle, so it's 85.1. That's gamma. Cool. Not too bad there, just a matter of typing it in and going. Good. Andy said all the angles equal to 180. So he knows eventually that when he puts this top row together, it should be 180. Well, he's got 2 out of the 3, so he's going to take 180 minus 72 minus 85.1, and that will tell you your missing angle. That will tell you beta. Beta is going to be equal to something 0.9. What is it? 22.9? 22.9 degrees. No. Okay, so this is a good thing to bring up. Pythagorean theorem. Can I do Pythagorean theorem here? I've got 2 sides. Why not? When do I use Pythagorean theorem? Right angles only. This is not a right triangle, so I can't do that. But the thing that's almost as easy as Pythagorean theorem is just set up law of sines. I've already got it set up. I've already got my power couple. I'm just going to continue that problem. Okay, I still got that. So sine of 72 over 21, that same power couple I used in the beginning, I can use it again. But this time I'm trying to solve for b, so what angle am I going to use? 22.9. Sine of 22.9 over b. Okay, go ahead and solve for beta. We're cross multiplying 21 times sine of 22.9 We multiply the two that we know, here and here. And then we want to take that and divide it by sine of 72. There's my answer that I was missing. B is 8.59. I like these little boxes as well, okay, because here's the other thing you can check real fast. Which angle was the biggest? 85. Is it across from the biggest side? Yep. Smallest angle was 22. It's across from the smallest side. So that's a really quick check. Okay, that problem itself isn't really hard. And it's not any harder here in a second either. But there's a second part to this problem. Because it was that naughty type of problem where it was an angle, side, side problem. Okay, angle, side, side, that's where we did the ambiguous case. Okay, I always remember if you have to do inverse sine in this problem, you need to check for a second triangle. Here's how we do this. Okay, the stuff they gave me at the beginning. Okay, so I'm talking about this stuff right here. These three things are still going to be true on my second triangle. So alpha is going to be 72 degrees. A is going to be 21. And C is going to be 22. All right, but this is what we did in bell work. Okay, that triangle could look like this. Okay, it could make a triangle that looks like this. But what could also happen is this leg could swing under and make another triangle. So it could go here, and it could swing across and make another one. So we need to check to see if it works. So here's how we do that. You're going to take whatever angle you found in the beginning. Okay, so which angle did we find first as we solved? This one, gamma, 85.1. Okay, you're going to find the supplementary angle. I'm using fancy words. Find the supplementary angle for the first angle found. What does supplementary mean again? They add together to get 180. So if I want to find the supplementary angle, all we're going to do is we're going to take 180 minus whatever the first angle that we found was. 180 minus 85.1 degrees. And what that's going to do, it's going to find me the second version of what this angle could be. It could be 85.1, or gamma could be whatever 180 minus 85.1 is, which is 94.9. 94.9. I like to call this one gamma 2, meaning it's like the second version. It just helps me to remind myself. Okay? 94.2 is what, 94.9 is what the other option is. Once we've stolen this angle that we found first and did the supplementary part, I really don't care about anything else that we solved for at the beginning. Okay, all of this stuff over here now is meaningless to me in terms of solving this problem. So I'm really going to make it go away because I don't care anymore. Here's all the information I need up here in this chart. Okay, up here in that chart. Oh, alpha's 72 and gamma's 94.9. What could I solve for next? Beta. I can solve for beta real easily. Beta sub 2 is going to be equal to, well, these three angles have to add up to 180. So 180 minus 72 minus 94.9. Those are the two angles you're subtracting. Don't look back at that first triangle at all. We don't care about that stuff. What's beta sub 2 going to be? 13.1? It's a little baby angle. So if it's a little baby angle, what's that tell you about the side that's going to go across from that 13.1? It's a little guy too. We're going to find it real quick. It shouldn't take super long. How could I find the last b here? What should I do to solve for it? Yeah, just do law signs again. You still have that power couple here. You still got these two things together. Sine of 72 over 21. I'm solving for b. So which angle am I going to use to solve for b? That beta angle, sine of 13.1. That will help me to find the second option for b. Okay? Don't let this be hard. It is a long problem, but the actual difficulty level is no different than what we've done before. Okay? We're cross-multiplying again. These two things multiply. 21 21 times sine of 13.1. Multiply those two together. So I multiplied these two, and then divide by sine of 72. My missing side is this little baby of 5.00. Since it's a side length, we go to 2 decimals. So it is really just 5. Different problem. It took a long time. Again, visually, here's what's happening. Okay, let me show you visually what's going on here. Here was our first option. Okay, you had this triangle right here with this 21. Or what they could have done was taken that angle and turned it under. So they took this angle right here and they flipped it, and it made this other triangle. There's 2 separate triangles, one with that little tiny 13.1 degree angle and one with a little bit bigger 22.9. Okay? Questions on what we did. Again, the big key here was after you found the first step, you subtract the supplementary angle, or to find the supplementary angle, and then solve from there. So looking at example 2, beta is 98, B is 39, and A is 22. Okay, I know that that's A and not alpha because there's not a degree sign. Okay, there's my setup. The first thing I'm always going to try to do with any problem here is law signs. Braylon, can I do law signs on this problem? Do I have 2 things across from each other? Do I have a partnership? Yep, you've got B and beta, so we can do law signs. So let's set that up. Sine of the angle over its side length. Okay, sine of 98 over 39. Iridiana, what are we going to solve for first on this triangle? Alpha. I've got A, so I'm going to use that to solve for alpha. So I'm going to do sine of the angle, so in this case it's alpha, all over 22. There's my setup. Go ahead and try and cross multiply and solve there. Yeah, we're going to do that here in a minute. So we'll find the supplementary in a little bit, but yes, the first angle I found. 22 times sine of 98 equals 39 times sine of alpha. There's my setup. So in my calculator, I am taking 22 times sine of 98. Then what do I got to do from there, Jalen? I multiplied these 2 things together. What do I need to do to get alpha by itself? Divide by 39. So we're going to get rid of that 39. So that's gone. Still not done, though. Austin, what else do I got to do to get alpha by itself? Inverse, yep. It's sine of alpha, so I want to get rid of that sine by doing inverse. So again, this is second sine, inverse sine of that number right there. So in order to type that back in real quick, 0.5586, we're going second, and then the negative key to give me that A and S down here. So that'll type that back in for me. Good. Yeah, it's not going to be a big deal if you close it or not because there's nothing after it. If I had to